Jantar Mantar, Jaipur, built by Maharaja Jai Singh II, who founded who's the founder of the city Jaipur. This is a UNESCO World Heritage Site. You won't miss it if you're visiting Jaipur. A great place for students of astronomy, astrophysics, anyone who is interested in looking at the objects, celestial objects. Have a good time and have a guide, and that's easy and clear in terms of what you want to see and in terms of your understanding. Have a great time seeing Jaipur.
Yantraraj. Yantraraj meaning astrolabe. The Yantraraj is an adaptation of an astrolabe, a medieval instrument for the measurement of time and the positions of celestial objects. This remarkable instrument seems to have interested Raja Savai Jai Singh greatly. He compiled and studied astrolabes of different languages available in his era and fabricated a comprehensive astrolabe for Jaipur Observatory. This circular instrument is marked with 360 degrees on it with divisions in gatis. Likewise, 90 altitude circles, prominent stars, constellations, and celestial circles are also marked on it at their respective proper places. It has a separate attachment for a sighting tube to be fixed in the center of the instrument. The instrument is used for measuring ascendance, altitude, time, and the position of the sun and that of some other celestial objects in the sky. It can also be used in the computations of celestial positions and their changes. The instrument also measures time from the positions of stars in the night and that of the sun in the day. Krantivritta. Krantivritta is declination, circle, stroke, ecliptic. The Krantivritta is an instrument that is meant to measure the celestial latitude and celestial longitude of an object in the sky. It is also used for measuring solar sign of the sun in daytime. Krantivritta consists of two brass circles of equal diameter pivoted together at one point on the circumference, maintaining an angle of 23.5 degrees between them. The basic circle made up of stone is called Nadivratta. It also remains parallel to the equator of the earth, while the outer brass circles can be rotated so as to be parallel to the ecliptic at any given moment. The Nadivratta has 60 degrees marked on its circular scale. Likewise, degrees of 12 zodiac signs are also marked on the outer brass circle. A sighting bar is provided to the outer ecliptic circle, which, when the outer circle is parallel to the ecliptic, can be rotated around the ecliptic pole. The sighting bar is rotated and is brought into the nearest alignment with the celestial object. When the sighting bar rests, the readings on the quadrant of sighting bar and brass circle gives the latitude and longitude of the object.
Khagol Gati Yantra. This astronomical instrument, resting on a pivot, consists of a plate in the middle, a Krantivritta Yantra on the right side, and a globe on the left side. The plate bears names of lunar asterisms along the ecliptic, their degrees, time in hours and minutes, and zodiac signs. The Krantivritta Yantra bears names of 12 months along with the respective zodiac signs. For 6 months, from 22nd March to 22nd September, the sun remains in the northern hemisphere, that is summer solstice. And for another 6 months, 24th September to 20th March, the sun remains in the southern hemisphere, winter solstice. On equinox days, 21st March, the vernal equinox and 23rd September, the autumnal equinox, when the great circle of the ecliptic intersects the great circle of the celestial equator, causing equal duration of day and night. We can observe these activities on the Krantivritta Yantra. On the globe, On the globe, we can determine the position of the sun on the cusp, which is the imaginary line that separates a pair of consecutive signs of zodiac or houses in the horoscope. This instrument gives us information about position of sun, planets and stars in respective zodiac signs, local time, sunset, sunrise, duration of day or night, celestial altitude, latitude and longitude, zenith distance and declination of sun. This instrument can be used during night also. You see a model of the solar system.
Khagol Yantra. This is a celestial and terrestrial globe used to observe the position of the sun on the cusp, which is the imaginary line that separates a pair of consecutive signs in the zodiac or houses in the horoscope. It can also be used to determine the exact position or favorable position of planets and stars in respective zodiac signs through astrometry during daytime. This instrument is shaped like a globe resting on a pivot which is inclined at 23.5 degrees on its axis.
Nadi Valaya, equatorial instrument stroke circular dial. The Nadi Valaya has two circular plates facing north and south, which are its dials. The wall of the plates is inclined towards the south at such an angle that the instrument remains parallel to the plane of the Earth's equator. The rods emerging perpendicularly from the plates are parallel to the axis of rotation of the Earth. The shadows of the rods move along the scales on the dial plates, indicating the local time. Each dial plate is divided into three circular scales, two of which have markings for the hours and minutes. The third scale is marked for the determination of the Gati Sun Palas, zenith distance. To the time indicated by the circular scale, a correction factor as displayed for the day at the observatory needs to be added to obtain the clock time. The dial plate facing south is sunlit from the autumn equinox to the spring equinox and is to be used for telling the time. The dial plate facing north is sunlit from the spring equinox to the autumn equinox and is to be used for that purpose.
Dhruva Darshak Pattika. Dhruva is pole star, Darshak Pattika is viewing plate. The Dhruva Darshak Pattika is perhaps the simplest of all the instruments found in the observatory. It is in the form of a small trapezoidal structure whose upper surface points towards the pole star on a clear dark night. The angle in the triangular wall is supposed to be equal to the latitude of the observatory's location, which is 27 degrees north. The instrument is erected on a 3.07 meter long and 54 centimeter wide stone masonry base. Its lower end is about 76 centimeters above the ground and the upper end 2.32 meters. This instrument was the compass of an earlier age. Lagu Samrat Yantra. Lagu is small, Samrat Yantra is supreme instrument. The Lagu Samrat Yantra is a sundial that can give the time to an accuracy of 20 seconds. The shadow of the triangular wall of the yantra falling on the eastern and western side quadrants tells the local time. The triangular wall with the angle inside the wall equal to the latitude of this location, which is 27 degrees north, is placed exactly in the north-south direction. The shadow of the triangular wall moves equal distances in equal time intervals on the quadrants. This movement is calibrated to read the local time. The western and eastern quadrants are divided into subdivisions, each of 6 hours, for the morning and afternoon segments respectively. Each hour is further divided into four 15 minutes divisions, which are subdivided into 5 minutes and 1 minute divisions, and each 1 minute division is subdivided into 3 divisions each of 20 seconds. The correction factor to be added to convert the sundial time to the clock time for the day is displayed near the instrument. The triangular wall of the yantra has a scale marked 0 degrees to 23.5 degrees north and south for measuring the decimation on the angular position of a celestial body with respect to the equator. Jayaprakash Yantra, repaired AD 1901. It's a representation of half celestial sphere rim represents horizon for finding all the positions of the heavenly bodies, invented by Maharaja Jai Singh. A is supplementary to B.
Brihat Samrat Yantra. Brihat Virat means large or great. Samrat Yantra means supreme instrument. The Brihat Samrat Yantra is a sundial that can give the time to an accuracy of 2 seconds. The shadow of the triangular wall, which is placed in the north-south direction with an angle equal to the latitude of this location, which is 27 degrees north, moves equal distances in equal time intervals on the eastern and western side quadrants. This movement is calibrated to read the local time. The western and eastern quadrants are divided into 6 hours each for the morning and the afternoon segments respectively. Each hour is divided in 15 minutes and later in 1 minute parts. The minute part has 10 subdivisions each of 6 seconds, each of which again has 3 small divisions of 2 seconds each. The correction factor which is to be added for the day is displayed in the observatory. It is used to convert the time obtained from this instrument to the clock time. The triangular wall of the yantra has scale marked 0 degree to 30 degrees north and south for measuring the declination, which is the angular position of a celestial object with respect to the equator. The Virat Samrat Yantra is the largest of all of Jai Singh's instruments, with a height of about 90 feet and a base length of 147 feet. The radius of each of the quadrants is 49 feet and 10 inches. Chakra Yantra. Chakra means circle, yantra is instrument. The Chakra Yantra is a ring instrument which measures the global coordinates of declination and the hour angle of a celestial object. The declination is the angular distance north or south from the celestial equator. The hour circle of a celestial object is a great circle that passes through the object and the celestial poles. The angle between an observer's meridian and the hour circle of the celestial body is the hour angle. The ring is pivoted about a polar axis at the southern end of the instrument. A sighting tube passing through the center of the ring is mounted. Using the movement of the whole ring about the polar axis and the movement of the sighting tube about the perpendicular axis, a celestial object can be sighted. The rim of the circle has a scale of 360 degrees, with each degree division is divided into 10 subdivisions. The plate around the polar axis pivot has scale of 60 gatis. Once the celestial object is sighted, the position of the sighting tube on the two scales can be used to read the declination and the hour angle. Ram Yantra. Ram is a name, Yantra is instrument. The Ram Yantra can measure the local coordinates of altitude and azimuth of a celestial object. I hope I pronounced that azimuth properly, whatever that is. The angular height of an object
from the horizon is the altitude. The azimuth is the relative angular position of the object measured eastwards, starting from the direction north. The complementary units are so designed that the shadow of the gnomon falls on a sector of one of the instruments if it falls in the gap for the other instrument. When the shadow falls at the top of the wall of the instrument, the altitude of the sun is 0. When the shadow is at the junction between the wall and the floor, the altitude of the sun is 45 degrees. Altitudes between 45 to 90 degrees can be read in a radial direction on the floor of the instrument. The circular ring, that is horizontal circle, near the roof of the instrument has 360 degrees scale for the azimuth along the circumference. Each degree division is further divided into minute divisions and the smallest division is 1/5 of a degree. The gamsa, that is azimuth, whatever. The digamsa is a cylindrical instrument that has a simple method of determining the azimuth of a celestial object. Digamsa or the azimuth of a celestial object is the relative angular position of the object measured eastwards, starting from the direction north. The instrument consists of a small knob, just gnomon, placed in the center of 3 coaxial cylinders. To determine the azimuth of a celestial object at night, an ordinary string is needed to be attached to the central knob. The other end of string is suspended over one of the outer cylinders using conventional weights. The circular rim of the cylinders is marked into 360 degrees and further subdivisions to indicate the azimuth. The string is moved over the rim of either of the outer cylinders and aligned to sight the celestial object. By this process, a vertical plane is defined that contains the object and a point on the horizon. The azimuth can be read from the marking scale on the rim of the cylinder where the string is resting. Likewise, to measure the azimuth of the sun, cross wires are stretched on the outer cylinder in east, west and north-south direction. Shadow of the center of cross wires on the circular scale tells the azimuth.